Well, hello everybody, and let us finish our discussion of the mole. Now, I guess the first thing to do is let's do a quick review of what we're dealing with here. Hey. Good. So we have the mole, right? Here's the mole, and we say we have a definition for the mole, and what I like is what? The mole is Avogadro's number, Avo's number of particles. Avo's number of particles. What is Avo's number? Well, it's 6.022 times 10 to the 23rd. What are particles? Well, atoms, ions, molecules, formula units, right? Formula units, good. That's what our definition is. We can say that I have, what are my units for this? My units for Avogadro's number are what? Particles per mole, or atoms per mole, or ions per mole, or molecules per mole, or per mole, or formula units per mole, right? So I can have 6.022 times 10 to the 23rd. Good. And then we have some calculations that we do with the mole. I can go from what? I can go from particles, I can go from moles to particles, right? Meaning I can go from moles to atoms or so forth. And how do I go from moles to particles? I multiply by Avo's number. I can go from particles to moles, right? And how do I go from particles to mole? I divide by Avo's number, right? I can go from grams to moles. And how do I go from grams to moles? I divide by what? Molar mass. I could go from moles to grams, and what do? I multiply by molar mass, and I can go from grams to moles to particles, right? And how do I do that? Well, I'm going to divide by molar mass, and I'm going to multiply by Avo, or I can go from particles to moles to grams. And how do I do that? I divide by Avo, and I multiply by molar mass, right? And we talked about, and I've referred to this several times, right? Molar mass. What is molar mass? Well, molar mass is equal to the mass of 1 mole of stuff, right? And how do I get the molar mass? Well, molar mass for atoms is what? That's equal to my average atomic weight on my periodic table, and the molar mass for compounds is equal to the summation, that's sigma for summation, of the average atomic mass of all atoms in the compound. Right? Good. And so that's kind of our overview. So let us go on and do a couple more problems, and we are done with the mole. Here we go. I have 2.41 times 10 to the 26. Cobalt 2 ions, how many grams? So what am I doing? I'm going from ions to grams. Ions are what? They are a particle. That's right. So we're going to go from particles to moles to grams, meaning how do I go from particles to moles? I'm going to divide by Avo. How do I go from moles to grams? I'm going to multiply by the molar mass. Good. So let's look at some. I'm going to do this using dimensional analysis. That's my favorite approach. If I have 1 mole of cobalt 2 ions, how many ions do I have? I have 6.022 times 10 to the 23rd cobalt 2 ions. Okay, now I also can go have what? 1 mole of cobalt 2, and that's equal to how many grams? Well, we want to go to my periodic table. Let's find cobalt. Where's cobalt? Eeks. Got to clean this mess up, don't I? Zoink! Cobalt. Looks like it's 58.93. 58.93, 58.93, 58.93. What? Grams of cobalt-2 ions. Good. So those are my equalities. And now I'm going to put together a beautiful equation, right? I want grams. How many grams? So that's what I want to end up is I want to end up with grams. I start with 2.41 times 10 to the 26th cobalt-2 ions, right? Times what? Well, there's 1 mole of cobalt-2 ions per what? 6.022 times 10 to the 23rd ions themselves. Good. Of cobalt-2, 1 mole of cobalt-2 divided by 6. Good. And so what happens? Cobalt-2 ions cancel, and I have moles, and then I have what? 58.93 grams of cobalt-2 over 1 mole of cobalt-2. And I look, hey, my moles of cobalt-2 cancel, and so now I just run the numbers with my beautiful calculator. I take 2.41, I use my double E key, meaning times 10 to the 26th, divided by 6.022 EE23 times 58.93, and what's my answer? Ooh, a big number, 23583. How many sig figs? I get 3 here, 4 here, 4 there. That means I can only have 3 sig figs. So this becomes what? 23600 and grams of cobalt-2. Got it? Makes sense? Excellent. All right, moving forward. Okay, this one's tough. I have 24.7 grams of boron trifluoride. How many grams of fluorine atoms are in the molecule? Okay. Well, where do we start here? This is different. I'm looking, I have grams of a compound, and I want to get grams of atoms of one particular element in that compound. Okay. Do I have a relationship between grams and grams? The answer is no. When I look at my formula, boron trifluoride, what does that represent? This formula says that I have 1 atom of boron for every 3 atoms of fluorine. This can also represent for us 1 mole of boron per every 3 moles of fluorine. And so our formula now not only tells us a ratio of atoms, it tells me a ratio of moles of atoms. Okay? Good. So here's the thought process. I have grams of boron trifluoride, right? And I can go from grams of boron trifluoride to moles of boron trifluoride. How do I do that? To go from grams to moles, I divide by molar mass. Good. Of boron trifluoride. Then I can go from moles of boron trifluoride to moles of fluorine. And how do I do that? Well, I have 3 moles of fluorine per every 1 mole of boron trifluoride. You guys see that? Yeah, there's a 3 there. That means I have 3 fluorines. So now I have moles of fluorine atoms. Now how do I go from actual moles of fluorine atoms to grams of fluorine atoms? Because I need to get grams of fluorine atoms. How do I go from moles to grams? Well, I'm going to multiply this by the molar mass of fluorine. 1 fluorine, because we're talking about fluorine atoms. And that will give me grams of fluorine atoms. You guys got that? That's the thought process. Are you ready to work it out? Sure. Here we go. We have 24.7 grams. 24.7 grams of boron trifluoride. And I'm going to multiply that by its molar mass. So that means divide it by its molar mass. 1 mole of boron trifluoride divided by, okay, what is its molar mass? Well, what's boron? Boron. Looks like it's 10.81. 10.81. Good. So, 10.81. That's my boron. Now, trifluoride times 3 times my F's. So, what are my fluorine? Where's fluorine? Looks to be like it's 19.00, right? 19.00. 19.00. 19.00. And this will give me what? This is grams of boron trifluoride. And so my grams of boron trifluoride cancel. Now I have moles, but I don't want to end up with moles. I want to end up with what? Oh, we have to go farther. Let's take this one step at a time. Here we go. Let's do some calculation here. So, 24.7 grams divided by quantity 10.81 plus 3 times 19, and I get 0.3642, and we're going to carry this through, and this is what? Moles of boron trifluoride. Okay? So now I want moles of fluorine atoms, which is going to be 0.3642 moles of boron trifluoride times what? 3 moles of fluorine per 1 mole of boron trifluoride. Got it? Good. So I multiply this times 3, and I get 1.0927. Remember, I'm only carrying 3 sig figs here, so those guys are not sigs. Moles of F. Now, why am I not worried about this being diatomic? Well, because I'm not talking about this as a molecule or a standalone entity. I'm saying the question is, how many grams of F are in this compound? So I'm looking at F alone, not F2. You guys got that? Good. So I have moles of F. Now, how do I go from moles of F to grams of F? Okay. So grams of F, it's equal to 1.0927 moles of F times what? Well, how many grams of F are there? Well, that's molar mass, right? What is F? F is 19.00. Good. 19.00 grams of F per what? 1 mole of F. Zoink! My moles of F cancel. What am I left with? Grams of F. So we'll take that 1.09 times 19, and I get 20.76, 3 sig figs, so 20.8 grams of F in what? 24.7? 24.7 grams of BF3. There we go. That is my answer. Woo! You guys think you can do that? It's not so hard. Just keep your head, right? What did we do? We went from grams of boron trifluoride to moles of boron trifluoride to moles of F to grams of F. Now you can see, folks, why it's so important to write down your units well. Got it? Let's try this one on your own. You got it? Here you go. 11.93 grams of sodium sulfate. How many grams of sodium are in this sample? Okay, bring me back when you're ready. Well, how am I going to work this? I'm going to start with, well, first I have to start with what is sodium sulfate. Sodium is Na, sulfate is SO4, 2 minus. What's sodium when it's an ion? +1. So that means I need Na2SO4. That's my sodium sulfate. So I'm going to go from grams of sodium sulfate to what? Moles of sodium, oops, there needs a 2 there, sodium sulfate, to moles of sodium, to grams of sodium. Got it? How do I go from grams to moles here? Well, I divide by my molar mass. How do I go from moles of sodium sulfate times moles of sodium? I multiply by the ratio, right? The ratio of sodium to sodium sulfate. And then here, how do I go from moles to grams? I multiply by molar mass. This molar mass is sodium sulfate. This molar mass is just sodium, right? I have only sodium here. You ready to give it a shot? Well, let's first get our molar mass of sodium sulfate. That's going to be equal to what? 2 times my molar mass of sodium plus 1 times my molar mass of sulfur plus 4 times the molar mass of oxygen. Whew. So 2 times the sodium. Let's go to our periodic table. Where sodium looks to be like 22.99. 22.99, 22.99, 22.99, 22.99. Good. Plus 1 times sulfur. What's sulfur? 32 point something, 32 point something. 32.07 it looks to me here, right? 32.07, 32.07, 32.07, 32.07 plus 4 times 16. I know oxygen. And this is what? Grams per mole. Good. So let's calculate this out. So 2 times 22.99 plus 32.07 plus 64, and I get 142.05 grams of sodium sulfate per mole of sodium sulfate. Yay. Okay, let's work it. I can do it now. Are you ready? So I start with 11 point, 11 point what? 11.93. 11.93 grams of sodium sulfate times what? 1 mole of sodium sulfate per 142.05 grams of sodium sulfate. Cool, right? So my grams of sodium sulfate cancel. I have moles of sodium sulfate. But what's my ratio of moles of sodium per mole of sodium sulfate? Here's my moles of sodium sulfate. How many moles of sodium do I have? Well, in every mole of sodium sulfate, I have 2 moles of sodium. Good, so that's my ratio. So I have now 2 moles of sodium per 1 mole of sodium sulfate. Okay, good. So then my moles of sodium sulfate cancel. I have moles of sodium. And then I have to do what? Grams of sodium. Oops, I'm going to have to erase that. Oink. Grams of sodium per mole of sodium. What's that? Grams per mole. That's molar mass. Sodium is what? 22.99. 22.99, 22.99, 22.99. Good. And if I look at my units, moles of sodium cancel, and I'm left with grams of sodium. Cool. So now let's run the numbers. 11.93 divided by 142.05 times, hey, don't forget that 2 times 22.99, and I get 3 point, how many sig figs? I get 4 sigs here, 4 sig figs, 3.862. So there are 3.862 grams of sodium in 11.93 grams of sodium sulfate. That means the rest of the mass here is in the form of sulfate, right? Okay, cool. Now here's one last question. Someone would say, well, Mr. Smith, aren't there just 1 sig fig here? No, this is a count. 1, 2, count. When you have a count, you have infinite sig figs. So there's infinite sig figs there. So I'd have 4 here, 5 here, infinite here, 4. So my answer would have 4. 3.862. If you can do that, you are a master of The mole. Cool. Next time we'll dive into some other stuff we can do with the mole. See you later. Ciao.